Anupama. First of all, I welcome all the guests, all the eminent speakers, and give you a brief description why we are here today. Some brief has been given by Anupama, but we all know that we are in the era where the change is occurring at a very fast pace. And with this change, we have learned two things: that one has to be the lifelong learner, and we have to be very adaptive, very flexible, and we need to understand what kind of mathematics we will be requiring in the coming future. And are we prepared for that? Are our children are ready for that? Do we actually know what kind of mathematics we shall learn? Can we imagine, can we visualize, can we apprehend that what will be the future requirements and what kind of changes are required in the content, in the curriculum, in the mathematical skills, and in the teaching pedagogies? So this discussion is actually a brainstorming in the future, and let's see what comes to us today. So every day we are meeting with 4 to 5 experts, and we are trying to understand from everyone, and let's see that how everybody visualize this situation and what holds for us in the future. So today we have a very eminent person with us, Dr. C.K. Ghosh. He retired as the regional director from the Indira Gandhi National Open University, and he was formerly the director, National Center for Innovations in Distance Education, which is the part of the Indira Gandhi National Open University. He was also entrusted with the responsibilities of being the nodal officer of the IGNOU Community College scheme, and also the nodal officer for the integrated MSc PhD program in physics under IGNOU, Indian Institute of Astrophysics Collaboration. He has more than 100 papers to his credit, but apart from all this, he has deep interest in mathematics and mathematics teaching, and he has very creative ideas for that. So I feel when in today's world we say that the boundary between the mathematics and the sciences shall be diminished, and we shall now start calling mathematics as the mathematical sciences. So let us try to understand from him that what are his views on this. Our another speaker, Mr. Sanjay Sinha, he is a very senior teacher in Sanskriti school, very senior mathematics teacher, and he's very passionate and committed mathematics educator. We have Miss Shuchi Goyal. She has a very vast experience of teaching, and she has worked right from the teacher in a public school to principal to education officer. So she has worked at in various roles, and she has her own understanding and her own experiences about the issues. So let me just, and then we have Professor Dharam Prakash ji with us. He's the guiding force for this discussion. And
no, ma'am. You are the guiding
you
one.
inspired. Sir, you inspired, and we started the discussions.
Yeah, I'll keep on
now,
poking questions.
now we all have started learning together. So,
Yeah.
Dr. Ghosh, I would like to know from you that what do you think that how much understanding of mathematics is required now, and especially after the class 5, because we are in technological era where everything is automated. So a child says that why should I study mathematics when everything is handy? Calculations करना है तो calculator is available. Graph plot करना है तो softwares हैं, और कुछ area find out करना है तो भी सब कुछ available है. So various kind of apps, softwares, everything is available. So in this situation, how we can say that how much understanding of mathematics is required?
First of all, thank you very much for this opportunity. I extend my heartfelt gratitude to Madam Anita Sharma and my co-speakers. It's indeed a pleasure meeting Mr. Dharam Prakash after such a long time, and that also virtually. And my gratitude and greetings to Ms. Goyal and Professor Sinha, who would be joining me in this discussion. I should initially say that I was not very much sure actually on what I have to deliberate upon. Of course, Madam Sharma had given me the hint that I'll have to talk about what kind of future shape mathematics curriculum and mathematics teaching is going to take up. So I cannot claim that I have organized my thoughts, and particularly with reference to her question that how would the scenario emerge when so many things are available technically. Now, the most important aspect about mathematics is that one has to feel mathematics. And this particular statement of mine, that feel about mathematics, should be there irrespective of the era. Whenever you talk with a student, say in the normal situation, in fact, this pandemic had created a tremendous existential crisis, and we have to fall back upon that, and we have to take that as a context. But at the moment, I'm talking as if the situation is normal. And with that also, I'm hoping and praying with all of you that the situation becomes normal with days to come. Now, if you ask the student how he handles his or her book of mathematics, so more often than not, he is interested with the exercise part. That is, every book of mathematics as if it is a problem set. What all is written in the text, what all is there in the content is not his concern. He wants to solve the problems, and even if he is not aware of the principle, even if he is just aware of the rules, so which enables him to solve the problem, he is happy. So the first thing is this feel of mathematics should come. No technology or with technology, feel of mathematics has to come, and that has to remain, whatever might be our course of action in the future. And this technological enablement, one thing occurred to me at the very onset, that this coding and decoding and the knowledge of number system has to come up in a big way. And that only should not be restricted to, say, when we say number system, again, we have the bogey of syllabus in our mind, and we'll be thinking about things like HCF, LCM, what is the remainder when such and such number is divided by such and such number. That should not be the case. Again, a feel of number system. And that has to be, that cannot be bound by a particular content of syllabus. Let me give you an example. The year that had gone by was 2021. Now, have you ever seen or have you ever observed that 2021 is a semi-prime? It is 43 into 47. Now, if you remove the first two, the numbers is 0 to 1, which is 21. That is 3 into 7. So that is also a semi-prime. If you remove the 0, then the number is 221. That is 13 into 17. That is also a semi-prime. If you remove the second two, the number is 201. That is 67 into 3. So that is also a semi-prime. And finally, if you remove the 1 of 2021, then the number that remains is 202. That is 101 into 2. That is again a semi-prime. So semi-primes galore. So this is what I mean by saying feel about mathematics. You see a number and try to dissect it, try to find out what all is happening with that number. Very recently, my friend got a car. In fact, that always excites me, the example of Srinivas Ramanujan, which all of us know. I'm not going to repeat that. Now, his car number was 6885. So, and knowing my knack about numbers, he asked me that, can you associate any particular significance with this number? So it immediately occurred to me that 6 plus 8 is 14 plus 8 is 22 plus 5 is 27. So this number should be divisible by 9. And then 5 at the end, so this should also be divisible by 5. So I divided it by 45 and the result was 153. And 153 is a narcissistic number. 1 cube plus 5 cube plus 3 cube is 153. And then what happened with the second case of that semi-prime? That was removing of that 0. The number was 221. 221 is equal to 13 into 17. It is a fantastic semi-prime number. First of all, it is the house number of Sherlock Holmes, 221B Baker Street, if you have read Sherlock Holmes. And then 13 and 17 are not only primes, they are EMIRPs. How do you spell EMIRP? E-M-I-R-P. So if you read it backward, if you read EMIRP backward, it is prime. So which number is an EMIRP? That number is an EMIRP. If you reverse the digits, it is also a prime. Of course, not when the two digits are same, like 11 is a prime and no question of reversing 11. But say 13 is a prime. If you reverse it, it is 31. So 13 is an EMIRP. 31 is an EMIRP. And the second factor was 17. 17, if you reverse, it becomes 71. So 17 is an EMIRP. 71 is an EMIRP. So the prime number 221, I beg your pardon, the semi-prime number 221, when resolved into factors, gives you 13 and 17, and both of them are EMIRPs. Now multiply 221 by 5. It is 1105. And this is a Carmichael number. What is a Carmichael number? A Carmichael number is the one which has prime factors. So the factors of 1105 will be 5, 13, and 17. And it would be called a Carmichael number if the number minus 1, here it would be 1104. 1105 minus 1 is 1104. It should be divisible by, if the factors are p, q, r, it should be divisible by p minus 1, q minus 1, r minus 1. So here the factors are 5, 13, and 17. 5 minus 1 is 4. 1104 is divisible by 4. 13 minus 1 is 12. 1104 is divisible by 12. 17 minus 1 is 17 minus 1 is 16, and 1104 is divisible by 16. So such a number is called a Carmichael number, and such numbers are very rare. The first Carmichael number is 561. It is 3 into 11 into 17. Please verify that it's a Carmichael number. And the third Carmichael number is Ramanujan's number 1729, which is 7 into 13 into 19. That is again a Carmichael number. So I just wanted you to be sensitized with these numbers, because number system is going to play a very, very big role, and a feel about number system in a very different way, not only through HCF and LCM and through several other issues which can be elaborated in some such other session at a later stage. So that should be in our mind for the future of mathematics. And then the other thing that occurs to my mind, particularly keeping the National Education Policy 2020 in mind, is the application oriented side of mathematics. Madam was referring to mathematical sciences. Now, why it should not be mathematical social sciences? Why it should not be mathematical art, mathematical humanities? So we have to see areas where mathematics can be integrated with other subjects. A teacher of social science and a teacher of mathematics we would like to see a situation where a teacher of mathematics and a teacher of social science will walk into the class together. We'll do team teaching on interdisciplinary areas. Now, what can be such interdisciplinary areas? Say in the case of history, well, there is no dearth of monuments in India, particularly in a city like Delhi. Now you go to Humayun's tomb, you see the plan, you see the elevation. Compare that with the plan and elevation of Taj Mahal, of Bibi Ka Maqbara, and you'll find the similarities. And when you go to the designs, particularly the worldly designs, you can see an array of symmetry, and these symmetries can be classified into translational and rotational symmetry. So study of symmetries will be doing a lot in the case of integration of art with mathematics. So study of symmetry and how it emerges from the coordination between translational and rotational symmetry will be a very, very interesting area of study. So that immediately occurred to me that how mathematics can be integrated with other areas. In fact, with the particular designs which you see in the Zafris of say Taj Mahal, or say in any particular designs which even the interior designers are also making, well, how that can be related to algebraic expressions. So this would be one more area which occurred to me, and different application oriented areas of mathematics. Say when you are traveling in a train, so what aspect of mathematics is coming to your mind? If you count the number of posts you have crossed, and say the distance between two posts are normally 10 meters. So if you can count them, you know the distance. And if you see your watch, you can calculate roughly the average speed of the train. So several such examples can be taken up. And then mathematics is the queen of science. Well, I am basically a student of physics, and I have found that the students of physics, particularly at the undergraduate level, when we did our higher secondary and came to the undergraduate studies, we were a little bit intimidated at the very beginning by seeing the long derivations. And our worry during an examination would be that how to do that derivation in the examination hall. We always used to get intimidated by the long mathematical expressions, because at the back of our mind, the thought was perhaps mathematics is a servant of physics. But that concept has to be changed. Mathematics should be made to emerge as the queen of physics or as the queen of science. Several areas of physics has emerged from mathematics. So we have to seek such areas where mathematics is creating physics. In fact, if you are aware about the laws of excess spectra, Moseley's law, now there, I'm not going to any kind of elaboration, but the lines follow the Bohr's atomic series, and so the numbers come as Rydberg by n square. So the transition lines are of the form 1 minus 1 square minus 1 minus 2 square, or 1 minus 2 square minus 1 minus 3 square. Now these quantities, 1 minus 1 square minus 1 minus 2 square, will be 3 by 4, come what may. 1 by 2 square minus 1 by 3 square will be 5 by 36, come what may. And from this mathematics, you can get the wavelengths of the X-ray spectrum. So that is fantastic. Similarly, this happens, of course, this is a very advanced subject. Some such thing also happens in the case of quantum Hall effect. Now, I'm not coming into that, but several mathematics, I'll just give one more example and then I'll stop for the time being. Say the famous Bohr's theory. Now, what I want mathematics to come as a subject of modeling, mathematical modeling. When we start a particular description, we start with axioms, hypotheses, postulates, assumptions, and all these lead to a model. So since I am a student of physics, I'm only remembering models in physics like the kinetic theory model or the Bohr atomic model. And in Bohr atomic model, there are two postulates. Now, the planetary model was already proposed by Rutherford when he could discover the presence of the nucleus by way of his famous alpha particle scattering experiment. And then thereby the plum pudding model, the Thomson model of the atom, was discarded, that nucleus was located at the center and the atoms are rotating around that. But I beg your pardon, electrons are rotating around that. But if negatively charged particle is rotating, then it would be generating electromagnetic radiation, and so thereby it will lose energy and collapse into the nucleus, leading to the complete collapse of the atom. So that was resolved by Bohr by his master touch. He said that the orbits will be stationary and they will be regulated by their angular momentum being an integral multiple of h by 2 pi, where h is the Planck's constant. I did this part a little fast because this is all physics, nothing mathematics, but mathematics comes at this relation. Angular momentum is equal to nh2 pi. It's a number pi is also a constant, which is a pure number. So the dimension of the right side, now here comes mathematics. Dimension of the right side is that of Planck's constant. Now, why Bohr had to choose angular momentum among so many variables? First of all, it is a central orbit. So torque is 0, and so angular momentum is conserved. So in order to standardize the orbit, he had to choose a conserved quantity. And angular momentum is one such. His second postulate is about the conserved quantity energy. And then it is a gift of the nature. Kindly note my point. And this is very, very mathematically significant, that it's a gift of the nature that angular momentum and Planck's constant have the same dimension. Had it not been the case, how could you have written the equality? Whatever might be your thought, whatever might be your experiment, whatever might be your critical thinking regarding the matter, unless the two sides are dimensionally consistent, you cannot place the equality sign in between them. So it's a gift of the nature that angular momentum, apart from being a conserved quantity in the case of a central orbit, it also has the same dimension as that of H. So from here, physics emerges, and mathematics is the queen of science. So just to summarize what all I have said in response to Madam's question, I don't know whether I've been able to give a satisfactory answer. One futuristic point is definitely a feel about mathematics, and through every aspect of mathematics, every part in the curriculum of mathematics, and most crucial among them, because the idea of coding, decoding struck me, and so I mentioned about number system. And then art integration in mathematics and making mathematics interdisciplinary with other areas, not only of science, but even social sciences. And then the third thing is application-oriented area of mathematics, how to make it significant with every real-life situations. And then the fourth thing, which is most crucial, that mathematics is the queen of science. These are the things which have occurred to my mind up till now. I'll still keep thinking about it. So thank you, Madam.
Sir, you touched 4 points. First, you talked about the feel of the numbers, which immediately has raised a question in my mind, because the way you talked about the numbers, our students nowadays, they are not very good at calculations, and they will not be able to respond to the numbers. They're not very friendly with the numbers, the way you spoke about them. So do you think in this context, giving them the exposure of the Vedic mathematics is important? Shall it be given so that at least they learn the fast calculation? Otherwise, some way we reject this idea of the calculations. But if they really want to feel the numbers and want to observe the pattern in this manner and the fast way, what do you suggest, that Vedic mathematics shall be part of the curriculum or not?
That can be introduced, but again, that does not satisfy the main part of your query, that if those things are technologically enabled through calculator, through softwares, through apps, why use now? If that be the situation, so first the value system, something has to be done for the value system. It is not only the utility aspect.
Yes.
It is also the in-depth knowledge about it, how all these things emerged, like log table. Now students will not know about log table. The tremendous effort put in by the two friends, Henry Briggs and John Napier, in creating the log tables. I still remember the first 4 figures of the mantissa part of the logarithms of 1 to 10. Log 1 is 0, log 2 is 0.3010, log 3 is 0.4771, log 4 is 0.6021, and so on and so forth. So first, that value system has to be created. It's not only that you are learning something because you are going to utilize it gainfully. It is also for the mental health. And once a student is convinced about that, then give him Vedic mathematics, not without that. Because in that case, if without that, if you give him Vedic mathematics, perhaps he will not give that much of honor and respect to Vedic mathematics, that it is due to the particular subject. But yes, a linkage to Vedic mathematics, a hint about Vedic mathematics will definitely create some kind of excitement. But again, it's a big if he or she is interested about the origin of the results.
जी, शुचि जी आप अपना कुछ बताइए आइडियाज।
सर जहाँ तक मैं सोचती हूँ, जहाँ सर ने कहा फील मैथमेटिक्स, मुझे भी लगता है कि स्टडिंग मैथमेटिक्स एंड अंडरस्टैंडिंग मैथमेटिक्स दो अलग चीजें हैं। जो हम जनरली अभी तक क्लास में कर रहे हैं, जब हम एक करिकुलम, एक चैप्टर वाइज जाते हैं करिकुलम में, तो हम स्टडिंग मैथमेटिक्स कर रहे हैं। और जब हम उन चैप्टर्स को इंटर रिलेट करते हैं या सब्जेक्ट्स को इंटर रिलेट करते हैं, देन अंडरस्टैंडिंग मैथमेटिक्स कम्स। फॉर एग्जाम्पल, जैसे मैं बहुत छोटा सा एग्जाम्पल दे रही हूँ, मैं मार्केट गई, बेकरी शॉप पर बच्चा आया, लड़की आई, उसने कहा भैया 10 लोगों के लिए कितना केक लगेगा, कितना सफिशिएंट होगा। तो जो शॉपकीपर था उसने केक का साइज दिखाया कि ये इतना काफी होगा। लड़की ने भी केक का साइज देखा, और जनरली व्हेन वी आल्सो गो वी लुक एट द साइज ऑफ द केक, बट व्हेन वी बाय केक it comes into weight. Then shopkeeper tells you the rate in terms of weight, not in terms of volume. तो हमने कितनी जल्दी चीज को किया, वॉल्यूम और वेट को, without knowing that we are doing some mathematics over here. लेकिन जब हम बच्चों को पढ़ाते हैं यूनिट कन्वर्जन, या जब हम बच्चों को क्लास में पढ़ाते हैं, तब हम वी आर नॉट टेकिंग दीज एग्जांपल्स एंड वी आर नॉट गिविंग देम एक्सपोजर दैट डायरेक्टली यू यूज दिस इन डेली लाइफ, एंड वी डोंट गिव देम प्रोजेक्ट लाइक वेयर व्हेन वी गिव देम सम क्रिटिकल थिंकिंग क्वेश्चंस, देन यू हैव टू प्लान फॉर द बर्थडे पार्टी, यू हैव टू प्लान इन टर्म्स ऑफ वॉल्यूम और इन टर्म्स ऑफ वेट और इन टर्म्स ऑफ मटेरियल। तो एक अंडरस्टैंडिंग मैथमेटिक्स और एक स्टडिंग मैथमेटिक्स में जो गैप है वो खत्म होना चाहिए। तो इंस्टेड ऑफ गोइंग चैप्टर वाइज, कहीं कहीं मुझे ऐसा लगता है कि करिकुलम जो है वो प्रॉब्लम्स इस तरह की उसमें आए कि उसमें कई टॉपिक्स इंडल्ज हो रहे हैं। ऐसा भी हो सकता है कि शुरू में हम चैप्टर वाइज पढ़ाएं, लेकिन बाद में कुछ ऐसे एट द एंड ऑफ द ईयर जितने हमने चैप्टर्स पढ़े, तो एक लास्ट 2 मंथ सेशन या 3 मंथ क्वार्टर ऐसा हो जिसमें जो कुछ हमने पढ़ा उसका एप्लीकेशन आ जाए। मतलब
मैडम मैं एक आपको प्रैक्टिकल एग्जांपल बताता हूँ।
हाँ जी,
क्लास 10 में मैथमेटिकल मॉडलिंग एक टॉपिक है।
बिल्कुल सर।
और वो किताब के आखिर में दिया हुआ है, मगर उसका कोई असेसमेंट में कोई नंबर उसके नहीं है।
सर बच्चों को मैथमेटिकल मॉडलिंग का मतलब ही नहीं पता। इवन टीचर्स भी कहती हैं मैथ्स में मॉडल बनाना मतलब मैथमेटिकल मॉडलिंग
नहीं, तो मैं ये कह रहा हूँ ना कि जब तक हम ये इन चीजों को असेसमेंट से नहीं जोड़ेंगे।
बिल्कुल सर।
कहीं असेसमेंट को भी मुझे लगता है इससे जोड़ना पड़ेगा हमें।
सर एक्चुअली टीचर्स ट्रेनिंग इज वेरी इंपॉर्टेंट, कि अभी टीचर्स ही उस तरह से नहीं सोच पाते, सब हर क्वेश्चंस भी नहीं बना पाते। जैसे अब क्रिटिकल थिंकिंग की बात करते हैं, हम सब क्रिटिकल थिंकिंग, लॉजिकल थिंकिंग की बात करते हैं, पर वो किस तरह के क्वेश्चंस हों, क्योंकि ना उनको क्लास में एक्सपोजर मिलता है और ना ही असेसमेंट में हम ओपन एंडेड क्वेश्चंस या क्रिटिकल थिंकिंग वाले क्वेश्चंस पूछ पाते हैं। अगर एक छोटा सा क्वेश्चन भी है और उससे रिलेटेड 10 क्वेश्चंस अगर हम पूछ लें, व्हाट इज गिवन इन द क्वेश्चन, व्हाट डू यू थिंक, हैव यू डन सिमिलर टाइप ऑफ क्वेश्चंस, व्हाट इंफॉर्मेशन डू यू थिंक इज रिक्वायर्ड टू गेट द रिजल्ट, व्हाट ऑल डू वी हैव, हाउ कैन वी गेट द रिक्वायर्ड इंफॉर्मेशन, व्हाट ऑल इंफॉर्मेशन इज प्रीलिम इंफॉर्मेशन व्हिच इज रिक्वायर्ड टू गेट द रिजल्ट। अगर उससे भी रिलेटेड हम 10 क्वेश्चन पूछ लें तो भी एक थिंकिंग एबिलिटी डेवलप होना शुरू हो जाती है। बेसिकली हम सोचते ही नहीं, हम सिर्फ ये देखते हैं इसमें ये फॉर्मूला यूज होना है और ये फॉर्मूला बच्चा अप्लाई करता जाता है, पर वो फॉर्मूला क्यों यूज होना है, व्हाई दिस फॉर्मूला, वो चीज हम नहीं बताते. यूज दिस फॉर्मूला बच्चे को भी पता है, हमने भी सिखाया, बट व्हाई दिस फॉर्मूला, व्हाट आर द एडवांटेजेस ऑफ यूजिंग दिस फॉर्मूला, इज देयर एनी अदर वे वी कैन सॉल्व दिस क्वेश्चन, इज देयर एनी अदर फॉर्मूला, कैन दिस फॉर्मूला बी मॉडिफाइड, व्हाट हैपेंस इफ दिस इज चेंज्ड. इस टाइप के जो क्वेश्चंस है ना सर, जब तक वो नहीं आएंगे असेसमेंट में भी और क्लासरूम टीचिंग में भी, तब तक वो अंडरस्टैंडिंग मैथमेटिक्स या फीलिंग मैथमेटिक्स वाली बात नहीं आएगी, ऐसा मुझे लगता है.
तो
संजय जी, आपको क्या लगता है?
हाँ संजय जी, मैं आपसे ये पूछना चाहूंगी, मतलब शुचि वाली बात को आगे कंटिन्यू भी करते हुए, साथ में अभी बहुत ज्यादा फोकस है इन वर्ड्स के ऊपर, मैथमेटिकल थिंकिंग, क्रिटिकल थिंकिंग, हाउ डू यू थिंक इट कैन बी इनकलकेटेड इन द चिल्ड्रन? एक तो ये, दूसरा अभी बहुत सारी कंट्रीज में एक नई टेक्निक शुरू हो गई है पढ़ाने की, वो ये बोलते हैं कि आप जो लैंग्वेज बैरियर है उसको खत्म करो, और बच्चों को बजाय इसके ये एक्स और वाई की भाषा में बात करने के, यू स्टार्ट टॉकिंग इन टर्म्स ऑफ जो भी एक्सप्रेशंस, जो लैंग्वेज एक्सप्रेशंस हैं, उसका वो ज्यादा से ज्यादा इस्तेमाल करें. वो इसलिए यूनिटरी अप्रोच को भी अब डिस्कार्ड करने लगे हैं, और खासकर से सिंगापुर और चाइना की बात अगर हम करते हैं, तो सिंगापुर और चाइना में तो ये वाले जो मेथड्स हैं, जो हमने जो एक एल्गोरिथमिक अप्रोच से पढ़ाना शुरू कर रखा है, कि बस डायरेक्ट फॉर्मूला आपको दिया है, आइडेंटिफाई की कौन सा फॉर्मूला लगना है यहाँ, और उसमें पुट करो वैल्यूज और आंसर निकाल दो. इस अप्रोच को उन्होंने टोटली रिजेक्ट कर दिया है. So what is your view on this? How we shall go about it? How mathematical thinking can be inculcated in the children?
At the very outset, let me first extend my thanks to you to have given me this platform to voice my opinion and put forward my viewpoints. And I must honestly say that I'm not really prepared with the answer to the question that you had raised first about the curriculum and all, because curriculum is something that is designed by a team of people, and we are simply to implement them in the system, and then we follow them. And the second point that you are talking about, I'll slightly deviate from what is being discussed at the moment. Because just before the start of this meeting, I happened to speak with Dr. Dharam Prakash ji, and started sharing with me as to how to improve on, or what changes are required in our system to improve the maths learning. And then he spoke about how badly our children are in international examination tests like PISA, going in that direction. So I want to share with you the main reason. I would say the responsibility lies with the kind of textbooks which are being written in our country. The origin is there. That quality of textbooks leads to bad teaching, and that bad teaching then further leads to bad performance in the children. So the origin starts from there. I'll cite several examples. I have got tons of examples where I can say that our textbooks are not following the concepts with consistency. There is a lack of consistency. And I'd like to just cite one example to begin with, like, for example, the concept of a function that we teach in our class and in pre-calculus. When I start with the calculus, which is actually the study of change, and Dr. Ghosh can connect with me because this is really used in mechanics of physics. So the concept of a function is introduced initially as a relation from a set to some other set, which is essentially a subset of the Cartesian product of A and B, and ultimately is a set of ordered pairs. And there is an immediate transition from this idea to the idea of function being a variable. In calculus, we say the function is the dependent variable and there is an independent variable. So the students are thoroughly confused. On one hand, you are saying that the function is a set. On the other hand, you immediately in the next topic, topic, which is actually written by some other author who has no coordination with the author who has written the chapter relation function. The author is talking about function now as a variable. So the students get thoroughly confused about it. On one hand, you are saying it is a set. How can it become a variable? And then it becomes a variable. So ideally, when I have this kind of a knowledge, I've done a lot of research on it. And I don't think in the days when calculus was perceived, the sets were ever in existence. When Leibniz and Newton or Cauchy thought about calculus and they contributed to it, sets were never in existence. Just because set theory came in and we are forced to use the idea of sets in the language of calculus, I find it unnecessary and a lot of discrepancies are there. So function can be simply introduced by the idea that there is a variable y which depends on another variable x, where y is the dependent variable and x is the independent variable. And if to each value of x from its domain, if there corresponds a unique value of y is said to be a function of x. And there is no point introducing function as a set of ordered pairs. So, but then the role becomes important for the teacher to explain to the children the difference between the two, and there is a connection between the two. But this is really not required. Second example, I have thousands of examples that I have to point out, but I'll just point out a few of them. Talk about the symbol square root. Square root symbol that we normally use, hardly anyone is aware. I have tested with hundreds of teachers. Hardly anyone is aware that this symbol stands for only the non-negative square root. When you write the symbol square root sign, square root of 4, it doesn't represent the negative square root -2, but the teacher forces the students to write plus -2. So the misconception has arisen from the kind of textbooks that we have, and the whole country is flooded with all kinds of cheap textbooks, and the teachers tend to follow them. This symbol actually stands for non-negative square root. It does not stand for the negative square root. So
sir, can I interrupt you for a moment?
Yes. Yes.
So why don't teachers have a say in the textbook development? Why don't they raise their voice? Say,
we do
no,
raise our voice. In fact, I have been in touch with NCERT for the last 20 years, more than that. In fact, I have authored some topics of NCERT textbook of class 11, so I know how the system is running. And the textbook was written in 2004 and has never been revised. And it carried so many errors, and we tried to influence upon them to change the and make corrections, necessary corrections. That was not possible, because then we were told that unless the textbook is further revised, these changes cannot take place. So, so I'm not only blaming the textbook of NCERT, but there are other textbooks which are in the market, and they are also influenced by these ones. And the problem is that the entire nation is misled by such books, and we are forced to teach wrong concepts.
And what do you have to say about assessment?
Assessment, of course, is a very important aspect of teaching. There is absolutely no doubt about it. But then a proper assessment can be done when proper teaching has happened and proper learning has happened, and the children have been given enough scope for self-learning. So assessment, definitely. Without assessment, we cannot check whether or not the children have understood the ideas well. And there has to be a proper way of assessing children. In fact, we do it in different forms. There is something called summative assessment.
I'm just interrupting. I think Madam's question was about teaching mathematics in vernacular language. Was it like that? Something like that? I think we have digressed from that point.
No, actually, I was
Little bit.
I was not asking about the vernacular language, but I'm just the language approach to solve the problems instead of using just the formula or
Let me,
the set procedure.
yeah, I'm coming to that point. I wanted to raise certain issues. One or two cases, one or two examples I've given you, but I have tons of examples. I'll point out one more thing about the idea of Bayes' theorem. Bayes' theorem, we have been teaching, and I spent my whole life now teaching Bayes' theorem. The idea is that there is in an experiment, there is a set of hypotheses that are created before the trial occurs. And the probabilities are well thought out, which are called priori probabilities. After the trial occurs, then their probabilities might undergo change, which are called then posteriori probabilities. The textbook seems to suggest that after the trial occurs and some event is found to have occurred, that event will occur or may occur with all the partitions of the sample space. Right. So A will find intersection with EIs, E1, E2, E3, E4. These are the hypotheses, and A is the event which is known to have occurred after the trial has occurred. So all of us say to the children that this event A has some intersection with all the EIs. When we draw the figure, there is a sample space and A is made to intersect all EIs. EIs means the hypotheses that are designed before the trial has occurred. Whereas I've just read a Russian book where there is an example created where A may not have intersected one of the hypotheses. It is not necessary that A intersection E1 will be non-empty. Whereas textbook seems to suggest that A intersection EIs will always be non-empty. So this is the kind of concepts that we teachers are forced to teach. It is because of the absence of a good quality textbook in the country. So that leads to bad teaching, and then further it leads to bad performance in the children. But as far as mathematical thinking is concerned, I am 100% in agreement with you that rote learning cannot work. That you just give the formula and ask the children to apply and get the answer or solution. This is no math teaching or math learning, absolutely. We do give them an algorithm ultimately, but algorithm has to be given with a reasoning at every step. At every step, the reasoning is definitely going to be there to find out as to why that step is being taken. So mathematical thinking is very much required. Simply by having a list of formula in mind and applying them in the problem is not going to work. So given a situation, sorry to interrupt again. Given a situation when the children should be able to find out what are there in the problem and what is actually required finally, and how to go about it, and what theorems or results or definitions could apply to get to the solution.
Dr. Ghosh, I want to understand from you mathematical thinking, computational thinking. Computational thinking is another new word which is being introduced in the NEP. So how do you see that? Because when they are talking about the mathematical thinking, they say that it is not only about thinking in mathematics or the mathematics problems, it is actually the way of thinking. So what special efforts shall be made in the schools to enhance the mathematical thinking of the students? Because we all know that there are problems with the teaching. We all know there are problems in the textbooks also. maybe because Sanjay ji has referred to so many books and the mistakes there. लेकिन मुझे तो अभी थोड़ा सा ये भी डर है कि कितने टीचर्स किताबें पढ़ते हैं और कितने स्टूडेंट्स किताबें पढ़ते हैं. As Dr. Ghosh has said it earlier, वो बुक्स को लर्निंग मटेरियल की तरह तो वो नहीं समझते हैं. They just consider this as a problem set. So it is only set of problems. तो वो सोच को कैसे बदला जाए, क्या करना चाहिए हमें?
Now, in order to develop thinking, you have to develop the art of questioning. You have to make the students ask questions. First of all, you have to create an atmosphere of de-intimidation. And it has been my experience, I'm not only talking about mathematics, for any discipline area, when you go to the class and you want to do some sort of a discovery learning, try to find out from the student, try to get the answer from the student, and you start asking questions. Now, if you look at the body language of the student, the immediate impression which the student gets is that the teacher is definitely asking a difficult question. So that should not be the case. And it's more than the students, it's the guardians. They are scared. So this particular thing has to be removed. A total situation of de-intimidation, as we are using the word friendly with numbers. So friendly with academia, friendly with study. This is, I have seen in the first meeting with the teachers, the class teacher comes and in a particular online meeting, it happened during the pandemic. And so that sort of induction program was taking place online. And the class teacher started saying, just, there was one sentence of greeting, and that also in a very lukewarm manner. And following that, she started saying about all the rules and regulations, and then these are the pass marks, and if you fail to secure the pass marks, you will not get promotion. Okay, these are the things to be told, but not in the first induction meeting. And if it has to be told, it has to be told in a very friendly manner, that, well, these are certain rules and this is the pass marks. And in the very unlikely situation of your being not able to get the threshold pass marks, this may happen. But from the very beginning, if you strike in a military manner, that causes intimidation. I think people understand the language of cricket. See what happened with fast bowling. During our times, we'll remember in 1962, Nori contractor got wounded, and it could have been lethal, it could have been fatal when he got hit in his skull. And 5 players, including Frank Correll, donated blood, and that's how he got saved. Now, when Hall and Griffith, the same bowlers, came to India, I remember in 1966-67, then the batsmen were very much intimidated how to play against them. So that's why batting did not develop. Then comes Sunil Gavaskar, and he wears a skull cap. So some kind of de-intimidation takes place. You look at the career of Mohinder Amarnath without helmet and with helmet. And now you have concussion substitute. So that's how bowling is improving, batting is also improving. So first thing is that a culture of de-intimidation in the classroom, be it the mathematics class, be it the physics class, be it the history class, that has to be done. And the students should be excited, should be inspired to ask questions. Einstein used to ask questions. C.V. Raman asked the question, why is the ocean blue? He did not agree to the explanation given by Lord Rayleigh. Lord Rayleigh explained the blue of the sky, but he could not explain the blue of ocean properly. And that's what struck C.V. Raman. So you have to tell the students to ask questions. Let us find out which student asked the best question. Isidore Rabi, who got the Nobel Prize in Physics in 1944, whenever he would return home, his mother will ask, "What, have you asked a good question today?" So you have to excite, you have to inspire the students to ask questions. You, rather than giving questions and trying to find answers from them, give a set of answers and ask them to create the question. Whenever we used to have a mathematics hobby club at our school, And the most of the puzzles we could not solve, but whenever we were able to solve a particular puzzle by Martin Gardner, puzzle by Sam Lloyd. Sam Lloyd is a great American puzzlist. And when we are able to solve that problem, well, our teacher will definitely congratulate us, inspire us. But at the same time, he will say that don't think you are intelligent. The person who created the puzzle is much more intelligent. So it is more difficult to create a question. I'm talking about a mock fight between question and answer. And then the answer says that I am great because without me, life cannot proceed, life cannot survive. And then the question said, but you do not exist unless I am there. So you have to tell this to the students that you have to ask questions, you have to raise questions, and you have to inspire them. There is no sort of particular kind of flow chart through which you can explain this thing. You have to find your own way to excite the spirit of inquiry in them. And if you permit me to say so, this is enshrined in the Indian Constitution. And I am not aware of the constitution of any country which has so clearly mentioned about these two terms, scientific temper and spirit of inquiry, as in clause 51A, item H. You read that you should have the spirit of inquiry and scientific temper. So you excite them about questioning. Critical thinking will follow.
Great. Thank you, sir. Your talk has been very inspiring, as usual. Ghosh, sir, it was very inspiring, and we learned a lot. That there could be a way out of inculcating critical thinking if we make our classrooms fearless, without any fear. As Rabindranath Tagore clearly says, where the mind is without fear.
Without fear and the head is held high.
Yeah.
So one last question I would like to ask to all of you. What is the relevance of teaching geometrical proofs in the class? We talk about the new concepts which are emerging, and although we have talked a lot about the mathematical thinking and how to inculcate the spirit of inquiry and the love for the subject, but I also want to understand that generally the students, they say that where in our life we are going to use the algebra and geometry which you are teaching us in the class. So what do you think, that how much it is relevant to teach them, and the way they shall be taught? Is there any change required in that? थ्योरम्स के प्रूफ कराने की जरूरत है हमें स्पिरिट ऑफ इंक्वायरी, तो तब भी सेटिस्फाई हो जाएगी जब वो टेस्टिंग करके देख लेंगे कि अगर एक थ्योरम अगर उनको एक रिजल्ट सीखना है कि सम ऑफ द थ्री एंगल्स ऑफ अ ट्रायंगल इज 180 डिग्री, तो उनके पास एक अप्रोच तो ये भी है कि दे कैन ट्राई आउट सेवरल ट्रायंगल्स. सो उसके बाद भी क्या ज्योमेट्रिकल प्रूफ जरूरी है? दिस इज अ स्मॉल एग्जांपल, लेकिन सारे कंप्लीट अप्रोच टुवर्ड्स द जो ज्योमेट्री है वो चेंज करने की जरूरत है और shall be retained.
I would like to respond to your question first. As far as my thought goes as regards the subject mathematics, the very soul of mathematics is one's ability to reason out. If you just give the children directly the statements and the results and definitions without any proof, the ability of reasoning children will lack. The students will have no idea of how the results were established, and many a time they will forget the facts. If you are very clear about the reasoning as to this was the reasoning that we arrived at this particular statement, then it is more likely that you remember this forever and ever. But if you are simply given a set of facts, statements, and which are going to be applied, definitely these the geometrical proofs and the statements are meaningful because they are applied in higher sciences. Maybe we are not aware of the applications. There are civil engineers who are looking at many applications of sciences, and especially mathematics. Without mathematics, civil engineers can't do anything. So there are definitely applications in higher course, which probably we are not aware of, and we are not able to tell our kids that this is the application that you find in this specific area. That is a lack of expertise on the part of the teacher, and that could be a possibility. But I don't see the possibility of scrapping the proofs from our system completely.
Okay.
And at the same time, I would like to add the inputs that are coming from various teachers nowadays. It has become a fashion to kind of include technology and make use of technology in your teaching. So that also leads to some extent, I have seen, because it has to be used with a caution, which is not being done by majority of us. Software is being used to demonstrate facts. And in those demonstrations, I don't see any mathematics learning happening. It is just the demonstration of facts happening. I would cite one example to you if I'm not taking much time from you. A simple example, the graphs of, say, a function and its inverse, if they are sketched, they happen to be reflections of each other in the line which is drawn from, which is actually y equal to x passing through the origin. So the graphs of a function and its inverse, they are reflections of each other in the line y equal to x. You do it with the help of software, GeoGebra or some other software, maybe Desmos, in the classroom, and you tell the children, look, this is happening. And hence you conclude that the graphs of a function and its inverse will always be like that. So what kind of mathematics learning has taken place? I don't see any learning taking place there.
तो ये अप्रोच गलत है ना कि सिर्फ डिमॉन्स्ट्रेट किया गया, अगर उसकी बजाय स्टूडेंट्स को ये अपॉर्चुनिटी दी जाती कि लेट देम ड्रॉ सेवरल ग्राफ्स and then they construct their own knowledge or on the basis of their observations.
Even that one will be a kind of verification of the fact, will never be a proof. So the word proof is being used in a very loose sense nowadays by most of us, so-called experts, academicians and all that. These are all using the word mathematics proof in a very loose way. And that is, I see deterioration on the part of mathematics learning. So instead of simply, this will be a good thing to do after you have explained, or maybe you demonstrate it in front of the children and then explain the reasoning behind it, because that is the soul of mathematics. So reasoning, if you just scrap it completely, then there is no mathematics learning happening. It is my view.
शुचि, आप कुछ कहना चाह रहे थे? आप अनम्यूट करिए, शुचि. Shuchi, unmute yourself.
Sure.
I think
चलिए
problem
आगे
is she is
चलिए.
not able to. हाँ जी.
जी.
तो डॉक्टर घोष, मुझे ये बताइए कि अब आपको क्या लगता है कि मैथमेटिक्स कंटेंट में और क्या नई डोमेन्स ऐड होनी चाहिए which can be sufficient for the future needs?
Now, regarding the previous question, I completely agree with what Professor Sinha has said, that proof should be fundamental, that it can be demonstrated through many other methods. That can come, but that would be secondary. Because again, if our stress, see, NEP 2020 is asking you to give stress on critical thinking, and without showing the proof, that critical thinking cannot take place. If you demonstrate or if you verify through certain methods, it is a sort of an empirical. It would be more equivalent to a kind of an empirical situation. But direct proof is required for the development of mathematical logic, a mathematical logical mind. And future, I told at the very beginning, those 4 areas. Others I'll have to think. Because frankly speaking, I didn't come so much prepared. Like issues like fractals,
Yeah.
fractals, then operations.
Hmm.
The operator formalism, which is so important. Like somebody asked me, I delivered a talk on application of mathematics in real life situations, and I picked up several examples. And he asked me the question that what is the application of a plus b whole square formula in the real life situation? Now, see, a plus b whole square formula you can apply by putting two numbers and you determine the square if the squaring is necessary, and suppose that squaring cannot be done directly. But it's a very, very hypothetical situation that I cannot work out the square of 7, but I break it up into 3 and 4 and use the a plus b whole square formula to do that. But what is the most important application of a plus b whole square? This also has to be thought from the point of view of critical thinking. Squaring, when you do that squaring, that mixed product comes. And squaring is not a linear operation. From the very beginning of mathematics, all that you are doing, unitary method, problems on time and work, problems on time and distance, problems on ratio proportion, in every case, you are considering linear variation. Otherwise, these principles will not hold. Even when you come to elementary statistics, when you are going to determine the mode and the median of a group data, well, you are considering linear variation of the frequency table. And similarly in life, say a couple has one child and the couple has a certain amount X of expenditure after that child, a certain amount of time they have to spend after that child. Now, when the second child is born, it doesn't exactly get doubled. It may be more than 2, it may be less than 2. So everything in life is not linear. And one lesson is given to us by this a plus b whole square, because squaring is not a linear operation. But say ddx, taking ddx of y1 plus y2 is equal to dy1 dx plus dy2 dx. So ddx is a linear operation. But if a operating on x makes it x square, then a operating on y will also make it y square. Then a operating on x plus y should have been x square plus y square, but there is an additional term. So which tells that squaring is not a linear operation. And then in a way, in a subtle way, it also gives us the lesson that everything in life is not linear, which we assume so tacitly without thinking. Whenever we do the analysis, like in cricket, this Duckworth and Lewis method, when the game gets scuttled due to rain or any such other condition, everywhere linearity is assumed. But everything in life cannot be linear, and the first approach towards that perhaps can be thought of to be coming from a plus b whole square formula.
Yeah.
But I think I didn't answer your question. You said that future, madam, I think let us do a little bit of more critical thinking on this question of yours, and we can meet once again.
Yeah, that needs more thinking.
Yes.
Sir, we can refer back to you again.
Hanji.
After some time, you can do some critical thinking about it, and then maybe you can come back to share your thoughts.
अभी तो सोचना शुरू किया है.
हाँ, जी.
अभी तो और बनेंगे, opinions बनेंगे, because we have randomly started talking about this. I think nobody is prepared.
Sorry, another thing, a very favorite area of mine, and madam would be knowing that application of mathematics in sports. That's a very favorite area of mine, and that should come. That should come in the syllabus.
Sir, actually, that is being said one and again, time and again, that sports integration should be there, but teachers also, they don't have much idea about it. कि ज़्यादातर mathematics के teachers sports खेलते नहीं. मुझे ऐसा लगता है, तो उनको समझ नहीं आता कि sports का integration करना कैसे है. तो उसके लिए तो हमें ना आपसे एक बिल्कुल training चाहिए first class.
जैसे
मैथमेटिकल
मॉडलिंग का बात आप कर रहे थे,
जी
तो ये नीरज चोपड़ा था जेवलिन,
हाँ जी.
तो उसका मॉडलिंग अगर हम प्रोजेक्टाइल मोशन से करते हैं,
Hmm.
तो then it has to be a point mass.
Hmm.
It has to be a point mass. A point mass moving in a non-resistive medium.
Hmm.
Lekin javelin is not a point mass. It has a particular kind of a shape, and then the space through which it is moving not only has resistance, has varying resistance throughout its journey.
Yes.
तो ये सब करके ना उनको मैथमेटिकल मॉडलिंग के बारे में एक्साइट करिए.
और दूसरा मुझे आपने उस दिन भी शेयर किया था, ये तो मैथमेटिकल मॉडलिंग करने के लिए सिर्फ मैथमेटिक्स को आप इन आइसोलेशन नहीं वो कर सकते हैं, दूसरे सब्जेक्ट्स के साथ भी इंटीग्रेट करना पड़ेगा ना. अगर आपको समझ होगी इस बात की कि एयर रेजिस्टेंस क्या है, प्रोजेक्टाइल मोशन क्या है, फ्री फ्लो ऑफ एयर क्या है, या पॉइंट मास क्या है, तभी मॉडलिंग कर पाएंगे इस केस में. So that kind of knowledge is also required, and that means the interdisciplinary approach has to be adopted.
Right, right.
So I think, Shuji, are you able to unmute yourself?